back. In our last class, we talked about the discovery of the electron. Today's class, we're going to talk about the discovery of the nucleus. Rutherford and his team were able to discover the nucleus between the year 1909 and 1911. They were able to discover this because many scientists wanted to know more about the atom, so a lot of experiments were being conducted, but they came up with their own model of the atom, which they call the nuclear or the planetary model of the atom, where they also said that J.J. Thomson's model of the atom is actually good but not that perfect. So they were able to correct the model and then came up with their own model called the nuclear or the planetary model of the atom. During this period, they were able to prove their point with an experiment called the Rutherford gold foil experiment or the alpha scattering experiment. Now, what really happened in this experiment? Let's see it. Now, what they did was that they allowed they performed a radioactive decay of radium in a lead material. Actually, why would they use a lead material? This is because a lead material, during the radioactive decay of radium, alpha particles are usually emitted. Now, alpha particles will not pass through a lead material. So this lead material will allow them to be able to take the alpha particles. So that was why they use the lead material. Now, now you can just see some lines here. This is to tell us that the alpha particles were coming out in all directions, but there was a little perforation on the lead material, so as to allow the alpha particles move on a particular side, and to direct them through this path to use it to bombard our gold foil. Now, they use the alpha particles to bombard the gold foil. And on bombarding this gold foil, the gold foil was very, very thin, such that the white consists of about 2 to 3 atoms, to tell how thin the gold foil is. Now, on bombarding the gold foil, the expectation was that the alpha particles should pass through the gold foil. Why? This is because, because J.J. Thomson viewed atom as a positively charged medium, which is just consisting of electron as the only particle inside of it. Just like, let's say, a watermelon, for example. Now, when you pick a watermelon, you just view it as our atom. The whole watermelon the whole watermelon and everything inside of it is positively charged, but then the seed are the electron. I think this will give us a clear picture of it. So, which means that there is nothing inside the watermelon. There's nothing inside the atom. The only particle inside the atom is the electron. And the electron is very, very small. The mass of the electron is very, very small. So the electron is very light compared to our alpha particle. So the alpha particle was supposed to pass through it without any obstruction. So, but there was a different observation. Now there's a different observation. This observation was that the alpha particles, some of them were being deflected at large angle, while some bounced back and then most passed through the foil. Now, Rutherford viewed it like he was just seeing it like using a 15 inches substance to hit or to fire to throw a 15 inches substance on or at a tissue paper. Then it hit the tissue paper and bounced back to you. So just imagine this. It's just like an impossible something. But that was what Rutherford observed, which made him to come up with so many conclusions. Rutherford then said that because he observed that only about 1 out of every 8,000 of the alpha particle bounced back to him. And it bounced back at angle 90 degrees. This line, I just have to make it this way, though it's supposed to just come straight back, because it bounced back at about angle 90 degrees. So this tells him that if only one particle will bounce back, in fact, for the particle to bounce back, it shows that the center must be heavy, must be very, very dense. That was the first observation. Then he said, if only one will bounce back, this shows that the center is very, very small. Then the next thing is that for some of the particles to be deflected, this shows that center is charged. and the charges must be positive charges. This is because we know positive and positive will repel, because the alpha particles are positively charged, so the center must be positively charged so that there will be repulsion, there will be deflection. They will repel and to bring about the deflection. And then he said for some of the particles to pass through, this shows that the atom is having a large, most of the atom is empty. So that is why some of the particles pass through. This will make the whole thing, this image will make everything much clearer to us. As you can see, this is the radium elements. Now, on bombarding the gold foil, it has, which consists of about 2 to 3 atoms looking at the wide of it. So you can see that this particle, one of the things on explaining this, they said for the alpha particles, the ones that bounce back because they hit this very dense center, which they call nucleus. Now that's why they bounce back at angle 90 degrees. Now, for some of the particles to be deflected is because they came close to the nucleus. And then for most of the particles to pass through is because the atom have a lot of empty space. And this empty space can still be seen as the space where the electrons are, because the electron cannot stop the alpha particles, cannot affect the alpha particles. So this was how they were able to explain their point. And then they came up with what we call the nuclear or the planetary model of the atom. And in their model, they compare the atom to the solar system, saying that just as the 9 planets are orbiting around the sun, and that is how the electrons are orbiting around the nucleus. And this was how they were able to discover this. I believe you enjoy or you like the class. You can feel free to subscribe, to like, and also to drop your comments. See you in our next video.